0.577,
Which is 0.
which is 0,
We cancel.
If AB it will be 4.
plus 0,
Plus 1.
F A B.
plus FAB
Minus
minus 4 is equal to 0.
So FAB equal 4.
FAB is equal to
4.
and now apply sigma FZ is equal to
0.
so
0.
minus 0.577 FAE
Minus
Minus FAC.
Would be equal 0.
equals 0.
that's
Equals 0.
FAC is equal to
0.
It makes sense because if you see the force is perfectly in line with the member AB. And when you are pulling, the whole force will go to this member AB. Is it difficult? Now let's talk about joint C. So at joint C, now you have how many unknown forces?
4. No.
AC we found it
So
0.
we have 3.
Three. One is this reaction here, one, another, only 3. You can call this reaction maybe CY or any other thing. Maybe, sorry, CY, this way. So, what next? Can you solve it?
Yeah.
Is it easy? For example, now this point will become your origin. Now if you want to solve, if you solve this joint, you will get the forces this member and this reaction. And if you want to solve this joint, you can also solve this joint. But there will be how many unknowns?
3.
3. But in this case, this reaction have two components, X and Y. Keep in your mind.
Also CE, that will have 2 components.
CE.
And X and Y.
This, I'm not sure. It seems that it is like this.
No, CE.
CE.
Yeah, CE. It has two components, X and Y only. You're right. You want me to solve any other joint? You're welcome. We can solve joint B. We can solve joint
I think E is difficult.
C. E, you should not go for E because E you have a different support. It has 3 reactions.
3 reactions.
Okay.
B.
So even without going to this support, you can solve the whole truss. And then at the end you can find out the reactions. You want me to solve any other joint or you can do it?
B. Can you
B.
solve B?
Okay, let's solve joint B.
What about tension and compression?
Yeah, tension, if your answer is positive, it means your assumed direction is correct. And if your answer is negative, it's wrong. It's a similar concept which you have used for 2D trusses. Okay. So the time here we have. Okay, let's solve now joint. Which joint? E? B? B. Now again, you can consider joint B as a reference and you can find out the position vectors of all members. How many members?
B. 3, 4.
But just let me confirm this reaction at joint B. This reaction is in 3D or in 2D? It seems like it's in 2D.
Yeah. And XY.
Only X and Y. No Z.
Z is 2 kilonewton.
Forget about that 2 kilonewton
Yeah,
for the
so
moment.
what would be?
We are talking about this reaction.
Uh,
It has only two components,
Yes, X and Y.
X and Y. We can call this maybe RB. Okay? You can call this maybe R reaction here. Okay, let's solve it. So what will be the position vector of PA? F BA.
Would equal to
4 kilonewton.
FAB, which we already solved.
We saw this.
Yeah, it will be
4 kilonewton.
4 kilonewton tension.
you already know that it is already 4 kilonewton in tension.
Yeah.
So 0 X
Minus 2 is in Y.
But there are another rule.
no now your this point is 0 0 0
Yeah.
and you know this force is moving away.
Yeah.
Now you have two ways, either to consider the position vector or directly consider the force as it is. Okay? Okay. So you can consider this force and this force you can consider 0 minus 4.
4.
Minus 4 kilonewton.
Minus 4.
It's 4 into minus J. So minus 4.
See, it's very simple. If you are considering the force away from joint, you mean it is you are considering tension. The same concept you have used here, the force away from joint. So it was positive. So you should consider this force as a positive. Okay? Because you assume the direction away from joint. So if it is away from joint this way positive, so it will be positive like this way here. Plus 4 plus 0. And what about F? BE.
B, E. We have
So you have the magnitude FBE multiply by
Vector
X
RB.
X2,
X2.
Y.
It should be cancelled out.
It will be the coordinates of joint E minus the coordinates of joint B.
Yeah.
How much is that?
So, and the X will be 0. 2 minus 2.
Y2.
0 0 هنا البي
0 0 0.
البي الحين خلاص 0 0
Origin. B is origin.
Okay, so X is 0.
X is
Y is 0.
no.
Two.
X is 2.
Sorry.
X is 2, Y is 0.
Y is
2
0.
and
Y is 0 and Z minus 2.
Should break one.
Divided by 8. Divided by square root of 8.
8.
Yeah, what is the answer? 2 over square root of 8.
1 over 4. 0.25.
square root of it.
Check it. 2 over square root of 8. One over under root 2. It is 0.07.
0.7.
Am I right? Yes. So x positive 0. This is x positive
Yes.
0.707 I
Plus 0.
j minus 0.707. Okay. So you can, if you want to write this force, multiply F B E I plus 0j minus 0.707 F FBE, K. Now, two forces, another force, FBD.
Doctor, FBA 4 into F will be
It will be itself, the force is equal to the magnitude.
there is no FBA 4.
See, in case of FAB, it has only one component. That is the Y component. There is no X or Z components. Okay? FBE. Now let's talk about FBD.
It will be just minus 2, plus 2 in K.
ماينس
2
تحت
It will be 0I
0 J
0J
plus 2 K.
ماينس
minus.
Go away from the joint.
تحت.
Now you have to consider the coordinate. You are considering the position vector of this joint.
But it's intention in joint.
You assume the direction, you assume this direction, but now you need the position vector. This is the position vector of this joint with respect to this joint. Okay, so it's fine. Okay. And any other force? 2. This force 2. P. This force, I'm saying this force P. Just 2K. Just 0I plus 2K. What about the reaction? How many components?
2
Now you have to assume the direction of reaction. You are considering this direction away from the joint, this way positive. So it will be having two components. This you can say Rx. So Ry. So which one is positive and which one is negative?
RY, what is this? RX minus.
Yes. So minus Rx cos 45
Plus RY.
No need to say any Rx or Ry because they are
IJ
R.
Doctor, we consider RY as positive, so before it should be negative, right? In FBA.
No, we assume it is tension, and if we consider this is in tension, it has two components. One is the Y component this way, and the Y from this joint you can consider positive this way. And X, this is positive X, so this component is going this way, it is negative. Okay, you can also say this. Instead of cos 45, you can say minus 0.707 R I plus 0.707 R J plus 0. Now apply sigma fx.
FBA should be FBA.
Sorry.
First one, FBA.
Yes.
Should be FBA on J, right?
You have a G have
You already have this force. This force is positive.
This is an IJ.
We consider it positive because of the assumption, right?
Because we already found this force positive before.
tension.
Okay, now tell me about sigma fx. So if you apply sigma fx, how many unknown?
2
The reaction
FBE and
You
reaction.
have to add 1, 2, 3. So there are two unknown. And if you apply sigma fy,
One unknown.
2
The reaction.
the reaction.
The 4.
0.707
One unknown.
R
We will get the value
Equal
of
Plus 4.
That's what?
R is equal to
Minus 4.
what is the answer? Tell me.
Minus.
5 by 6.
Good. And now you can solve.
FB.
Before going to f, now you can apply sigma f
X.
fx. So if you apply sigma fx, you have to put r is equal to minus 5.6. So you will get 0 plus 0.707. This is sigma fx. This is sigma
FY.
fy. 0.707 FBE minus,
It's minus minus, right?
yes, so 0.707 into minus,
Will be minus 4.
yes,
Plus
plus 4.
Plus.
So FBE will be equal to the reaction,
Yeah. It would be positive 5.6.
negative 5.6.
Yes.
Okay, now you have R, now you have FBE. So you can apply sigma Fy now, sigma Fz.
Until it.
Minus 0.707 FBE. So it will become plus 4. Put FBE here. You will get plus 4K.
Minus of BD. Plus 2.
Plus 2.
So FBD is equal to
6. Positive 6.
that's all.
Take out of time. The result is better.
It's your choice. I leave this totally up to you.
These mistakes.
IJK.
So, I mean, to write a vector in the force in the vector form, you should be having a good knowledge of the coordinates and the forces. If you want to use a method of joints, it's totally your choice. I do not write on the paper during your exam that use the method of section and the method of joint. I will not write it for your convenience. I will leave this up to you. But I know if I write the method, it will be much easier for you. Because if I don't write the method, you will go for the method of joints. I'm sure. Very few try to cut the section and they do some mistake. Well, in my last class, I didn't teach this. I mean, the last time I taught structural analysis, I didn't teach space truss because I suppose that they already have finished in statics. But because most of you not complained, most of you informed me that you have not studied that this space truss during your statics class, so that's why I have done the kind of review. Okay. But I think I have taught this. I remember.
We studied.
Okay.
We have to study.
It's just a quick example, and they don't bring it to the exam. Well, only one teacher brought it.
Well, it's the teacher and you. Any question relevant to this space truss?
It will become an exam. Because we studied it before.
Yeah, teacher, it's too easy, teacher.
It's too easy, I know that. You know, if you do not study something, it's not in your exam. But if you study something, and I cannot rule it out, but the possibility is very low.
Alright.
Okay, I cannot rule it out that it will not come in exam, but the possibility is very low. Okay,
But it takes a lot of time. Easy, but
maybe I can give you a simple space truss. Okay, that's all for today. If you don't have any question, I leave you for your rest of the activities and thank you for this class. Thank you. Have a good day. Thank you.